So the P is here. If we have removed some area, got damage, we cut out the area and then we determine how much loss the load carrying capability of this area after you remove them. For the skin is a bit unique because skin itself for the aircraft, for large transport aircraft, it is just like a barrel. This is a fuselage. Okay. The fuselage, if we take part of the skin, cut square section of the skin will have forces in direction here and also forces in this direction. So it has a shear force because it's just a thin plate. So the forces is in the thickness. Okay, the forces is inside here. So this is shear force. Shear force, shear stress. So P shear and shear stress. So we're dealing with these two shear. So if you put this up, if you got the skin damage, say certain the section of the skin, we have a fuselage here, skin just cut off part of it, and then we have that section damage. Okay, damage. Similar concept that we use, we cut off the area. Cut off the area, remove it. And still we have to put the doubler to repair. Since this is a fuselage skin, the repair may be flush. But the concept is the same. You have to put the patch to repair and put the rivets. Okay, put the rivets all around the patch. And the cross section view. So this is now is a cut. Then you have this as dotted line because it's hidden under the doubler. But if the doubler is flush, then this line is solid because it's nothing hidden, because the doubler will be behind. Okay. So same thing. If we look at the cross-sectional area, we have in this situation we have plate, we have a doubler. So this is skin, and we have a cut somewhere here. Which you fill up with another piece of skin. So this is a filler. Okay. So we have rivets. So same concept of the angle repair. Only the problem now is how to determine the force, the load loss. You still have to look at the load loss because it's still loss area. As you lost area, you lost load because now as you lost the area, your area become low. Okay, as you lost the area becomes smaller. Over here, force over area As the area becomes smaller, this is maintained and the stress become higher. And the stress should not be, this should be less than the material itself. If the material field is at 240 gigapascal, and then when you cut off the area, it should not be higher than 240 gigapascal. Or if it goes higher, then the part will fail. So that is the main problem that we do. And the whole exercise that we want to do is to look for these stresses. Okay, how much loss? For this situation, we have to calculate the load loss in this direction. And also in this direction. And we also have load this direction. Load in this direction. We also have load in this direction. We also have shear here. So this is a tension load due to pressurized, because the aircraft is pressurized. Okay, this is the longitudinal load. Longitudinal. So we have to get the total load by resultant. So the load, total load loss of tension plus load longitudinal square root, you get the total load resultant. Okay, any question? So now instead of just single load, here we do have load in two direction. If we can see, if we make here as is a axis system, so this is y, this is x. So now we have load in the x and y direction of the skin, because the skin also experience pressurized loading, which it has tried to expand the fuselage, and the skin will experience tension, and also other standard loading where the aircraft fuselage is basically bent during flight because all the load attached to it, the engine, the empennage. So all those are giving loading, and the loading also will be reacted to the aircraft structure, and the aircraft structure tend to bend, tend to deform because of the load. So that load is longitudinal load, and we also have load in the uh, circumferential load, which is we consider tension. Any questions? So yeah,
the cutting part is the one that on the black side, right? On the picture.
yeah, we cut the area here, yeah, and then put doubler over it. So that's why we got dotted line, because the cut is behind the doubler. Okay.
Okay, sir.
Okay. So it's similar. If we do have here, say this cut is 10 mm, and the cut here is 20 mm, and then we have to calculate the tension. So you have to calculate the area. Say this is section A, area A, region A. This is region B. Say the region A area equal to 20 over 1000. You need to transform to meter times, say the thickness, we say 1.2. We maintain 1.2. That one is another 1000. And what do you get? Any answer to that? Wait, let me put on the Excel.
Zero
So,
point 0.0002.
okay, 0.002 unit
M squared.
meter square.
Squared.
Okay. How about the region B? So we have 10 over 1000 times 1.2 over 1000. Okay. What do you get? Give me a number.
One times 2. 1.2 times 10 power of negative 5 meter squared.
Okay. 5, 1, 2, 3, 4, 5.
So yeah, the top one is 2 4, sir.
So the top one is 2.4, sir.
Yeah,
2,
4.
4. Okay. So 1, 2, 3, 4, 5.
Send it also the 10 to the raised power minus 5, sir, for the up one.
Huh?
Sir.
1 2, sir.
1, 2,
The
4.
bottom one.
Oh,
No,
1.
no, the bottom one is 1 2, not 5.
Oh, 1,
1 2.
2. Okay. So here is 2.4 10 to the minus 3. Am I right?
Minus 5, sir.
Huh?
Yeah.
Huh?
That's a minus 5,
Minus
sir.
5.
Minus 5,
5.
sir.
Okay,
Yes.
this is 5.
Yes, sir.
Good, good. So 1, 2. So here. Am I right? Okay. 1, 2, 3, 4, 5. So we got dot here. Okay. So 2.4, this one 1.2 10 to the minus 5 meter square. Meter square. So if the stress of the material alloy 2024, say we just put some number for the purpose of this analysis, 200 megapascal, which is 200 10 to the 6 Newton meter square. Okay. We also need to have shear. Okay. Shear, say you put shear is say just to make the number easier for us, 300 megapascal. Okay. So it is 300 10 to the 6 Newton meter square. So why we need that? Because we have a cut. Okay. The cut here, we have a load. The load is we have so this is not correct. Exaggerate. So it is bigger in this direction. Okay. So what we have the load. Okay, the loading is we have a load here. Okay, we have a load in this direction. We also have load because of the pressurized in the direction and in this direction. Okay. And also, since it's a cut, I say again, we have the shear. We also have load, shear load along here. If you don't understand this, you go back to mechanical material. So we have shear load here. Same here as you do the cut. Okay. Along here we have shear. Okay. So that's how the skin has been loaded. If you cut off, you have the load all around it, and you have also standard load in the X and Y direction. And the load along the skin is the shear. So this is tension. Okay. We deal with this tension. We use this tension. We use this as tension for the stress. This is stress. Here we use the shear. Shear. Okay. Shear. Any questions so far? So what is the load here? Tension. Here is we do have 200 time. What is the area? 2.4
0.4
times 10 to the minus 5. What do you get?
4.8 times 10 power of negative 3.
Sorry, this is not stress. This is stress. We use stress, but here is the P. Okay. We use stress. So the P, the load is
4.8 times 10 power of negative 3.
negative.
4.8.
This is
You didn't
200
use the power of
megapascal. This is
yes,
megapascal. Actually, it's 200 times 10 to the 6. Okay, don't miss this. A lot of people miss during the exam, then it's not good. Time 2.4 10 to the minus 5. What do you get?
4,800.
4,800 unit
Newton.
Newton. How do you get Newton? So how do you get Newton? I show you. This is Newton meter square. This is Pascal. Time the area meter square. We cancel. That's why when you do the analysis, you carry the unit, because the unit will actually validate whether your answer, your calculation is correct or not. So 4,000, this P also here is 4,800. Okay, now what is the shear? This is P tension. P shear. Okay, from here P here. So what you do is you 300 10 to the 6 time the area here is area shear along here is 2.4 times 10 to the minus 5. Any answer?
So 7,200.
7,200 Newton. So here along here you lost 700
More area.
720 Newton. And you lost tension this much. And it's the same all over because this is same standard material. So because equilibrium, we're the same here. Here in this side is the same. And for this, P tension equal 200 10 to the 6 times 1.2 10 to the minus 5. So what's the answer?
2,400.
2,400 Newton. And here P shear is sorry, I'm wrong. Is it okay, 300. Yeah. 300 times 10 to the 6 times 1.2 10 to the minus 5. What do you get?
3,600.
3,600. Okay, now we have shear and we have tension. So what is resultant? P resultant will be 2,400 square plus 3,600 square root. What do you get?
Sir, 4.
Huh? What's the number?
4,326.66. 26, sir.
26.
Yes,
26 point
26.66.
0.66 and then we ignore. We just take the one. Okay. So that is the total load now in this area you have to deal with. And here is what you get. So here we have 4,800 square plus 7,200 square root. What do you get?
8,000
8,653
653.
Newton. Okay. What does it mean now? What does it mean now here is when we have the cut, okay, we have the cut here. So the load that you need to deal with this area. So when you lost this area, this is how much you lost. Okay, this area, you put the doubler. Okay. The doubler need to carry 8653. Similarly, when you have the doubler here. Okay. Okay. Similarly, when we have here. Similarly, that we have here is 4, 3, 2, 6. However, we cannot just put the doubler. It may work, but it will have many area of higher stresses. So that's why the doubler that we put in is as one big piece. Okay. That's why some doubler, you see they cut off this area. They chamfer the area. Okay, you can see the chamfer the area. They chamfer the area. Because the load is already carried by this section. So they carry by this. It's carried by this. It's carried by this. Okay. Questions?
I think okay, sir.
Okay. So that is how we calculate the load loss for the skin cut out. So the rest is straightforward. If we're looking at the fastener, say if you're installing one here, two here, two here, two here, two here, we have one here. Okay, that is the doubler. There is the fastener rivets. So if we choose a rivet, say the rivet is if the rivet is 500, okay, the rivet is rivet strength. I think I show you the table already. Say is 500 Newton, and then you install 2 rivets in a row. So it's 2 rivets here. 1, 2, 3 row. Okay. So 2 rows, 1 row here will take 1000. And you have 3 rows which end up with 3000. So is it enough to carry 4326? Is it enough? So we add 2 more. So it become 4000. Is it enough? So we add more. So we got 1, 2, now become 5000. Okay, now we add more. We have 5000. Okay, now become 5 rows. 1, 2, 1, 2, 3, 4, 5, and we got 5000. Is it enough? How to check enough? We have to calculate the reserve factor, which is 5000 over Okay, 4, 3, 2, 6. Okay, 5,000 over 4, 3, 2, 6. What do you get? One point 1.2, is it? 1.1. 5,000 over 4,326.
1.15, sir. 1.16.
1.16. So it is 1.16 is positive. So it is good.